Hi, this is Shravya. The topic presentation is Personal Expense Tracker. This presentation covers the design and implementation of a personal expense tracker app built for Android using Firebase, RoomDB, and modern design patterns. And next, this is the overview of PET. PET stands for Personal Expense Tracker. It provides user-friendly expense tracking, secure login, geolocation, tagging, and spending analytics using Android's latest frameworks and APIs. And next, this is the key features for this presentation. User authentication via Firebase, expense recording with geolocation, Local Maps API, expense history with filtering by date category, spending analytics using MP Android chart, persistent storage with room database, performance optimization using Kotlin Corotness. Uh, and next, this is the objectives. The main goals were to build a UI following material designs, ensure robust functionality using the Android SDK, and structure the project modularly using UML and software design patterns. And next, this is the use case diagram. Primary actor user. The use case diagram defines how users interact with the app, registering, logging in, adding expenses, viewing expense history, and analyzing spending habits. This is a visual representation of the use case. Mm, Here are some here are some use cases like users register with Firebase, login securely, and record expense with the optional location data, which is saved in the local database. Uh, the user navigates to the registration screen, enters their details, and login. The user enters their email and password and submits. Record expense, the user enters the expense details like title, amount, data, location. The system validates the input, stores it in the database, and confirms the successful entry. Then next, view expense history. The user requests to view past expenses. The system fetches the data from the database and displays it. And next, view analytics. The user requests analytics on the spending. The system fetches and aggregates the data, then presents it visually in the chart like pie chart and bar chart. Users can review past expenses and apply filters. The analytical section visualizes the spending patterns via charts, helping them understand with financial behavior. And next, class diagram. Here are some key classes. This UML class diagram breaks the app into UI, controller, and entity layers. It shows relationships between components like users, expenses, and services such as cloud sync and authentication. The key classes are UI layer, control layer, entity layer, relationships. Mm, this is the UML class diagram of the application. Uh, This is the design patterns. The project uses key patterns, MVC for suppression of concerns, respiratory for data abstraction, singleton for managing Firebase authentication, and factory for generating different chart types. Benefits, modularity, scalability, maintainability. This is the sequence diagram. Here are the list of sequence diagram. This diagram outlines the flow of four keys: user and actions, registering, logging in, adding and expense, and viewing insights. Show how each request moves through the system. In register, it moves from user to authentication UI, authentication controller to authentication service to success or failure, and login user to authentication UI, authentication UI to authentication controller to authentication service to successor authentication token. Add expenses, user to expense UI to expense controller to expense respiratory to expense added confirmation. In view sites, user to expense UI to inside controller to expense respiratory to chart data. And next, this is a visual representation of the flow of events in the application. And next, this is the user registration process. User register via authentication UI, submitting email and password. Authentication control validates with the Firebase, returning success of value feedback to the user. Next, this is the user login process. In this, login involves entering credentials validated by authentication controller via Firebase. Successful authentication grants home screen access with a user feedback. And next, adding an expense, user input expense details processed by expense controller and saved to room database. A confirmation is displayed with optional geolocation tagging. And next, fetching and displaying analytics. Analytics request triggering insights controller to fetch and process expense data, generating interactive charts display via the UI for user analysis. And next, user interface diagram. In user interface diagram has key screens features. In key screens, login or register, email or password fields with validation, home dashboard with navigation to add expense, history, analytics, expense entry, form for title, amount, data location, map view, history list view with filters, data category, analytics pie chart showing spending by category. In futures, lighter dark mode toggle, responsive designs with constant layout, material design principles. PET's UI includes login, register, home screen, expense, entry, history, and analytics screens, featuring lighter dark modes, responsive layouts, and material design principles. And next, this is the key screens. The login or register screen offers email or passwords fields with real-time validation, ensuring secure access with a clear user-friendly layout. And next, home screen. The home screen, a central hub, displays a personalized greeting, recent expenses, and quick access to add expense or view history. And next, this is the expense entry screen. The expense entry screens provide fields for title, amount, and data with data pickers and optional Google Maps. Location tagging for streamlined input. This is the analytical screen. The analytical screen presents a pie chart via MP Android chart, interactive for category details with data range, selection for financial insights. This is the testing plan and results. Testing covered registration, logging, expense savings, and analytics. All test cases, including edge cases like invalid inputs passed, ensuring reliability. And like this is the conclusion and critical evaluation. PET excels in UI designs and modularity, but faces could sync latency, addressed via caching and lacking biometric lagging. Solvable with biometric prompt. Future enhancements include budgeting and multi-language support. This is the references for this presentation. References include Android Room, Firebase documentation, and MP Android chart tutorials. Cited by Cardiff Metropolitan University guidelines. Thank you.